Good afternoon, ma'am. My project is a light safety system. Abstract is the extended finite state machine is a powerful model that can capture almost all the aspects of a system. However, testing from an EFM is yet a challenging task due to main problems, path feasibility, and part test data generation. Also, optimization algorithms are efficient. Their application to EFSM testing have received very little attention. Our aim is to develop a novel approach that utilize optimization algorithms to test from EFSM models. Introduction to our problem. Errors in a system, if not eliminated, can lead to unexpected outcomes, and testing is therefore an important process. However, manual testing is slow, expensive, and error prone. Thus, automation is desirable. Model-based testing represents the system specification in a form of a model, which is then used to derive tests that can be applied to the system implementation. FSM and external FSM are commonly used for the purpose of model-based testing. An FSM can represent the control parts of a system such as a traffic light system. However, an EFSM is needed to represent more complex systems, usually with control and data parts, such as communication protocols. An EFSM essentially comprises states, variables, and transmission among states. Generally, a transition has guards and actions over the machine variables, where guards must be satisfied in order for this transition to be taken, and so for the associated actions to be executed. And the guards must be satisfied because of that. The EFSM is a powerful approach for modeling and has been widely applied to many areas in order to derive test sequences from the system of interest. Despite its popularity, testing from this model is still a challenging task due to two main problems. The one is the task feasibility, and the another one is the fast test data generation. Due to the presence of guards and actions, a conflict may occur among two or more transitions in a given transition path. For example, a transition action may set a variable x equal to 0 and the next transition guard sets let x greater than 0. Such a path is infeasible, and so it is impossible to find test data that can trigger it. However, determining if a given path is feasible in advance is undecidable. In addition, the development of good methods for this problem is an open path feasible. Then a set of input values is required to trigger or exercise this path. Nevertheless, finding such a set is difficult task since the input domain is usually quite large, but the required values are just a small subset of this domain. There are many approaches that study these two problems, the past feasibility and the past test data generation by converting AFSM to FSM models, for which many test techniques are available. The conversion is conducted by the either abstracting the data away from the EFSM, so it is FSM, or expanding the FSM to FSM. While the first approach doesn't guarantee that the path taken from the EFSM will be feasible in the corresponding EFSM. the other approach can easily load to the number of the states in the resultant FSM being prohibitively large, although optimization algorithms are recognized to be efficient for testing purposes. Very little attention has been paid towards investigating their application for testing FSM. Therefore, the aim of is to tackle these two problems and develop a novel approach to test from FSM model by employing optimization algorithms. Thank you.